Hello guys, and welcome to our statistics sessions. So today we'll be doing our systematic sampling. In our previous video we had done the sample sampling technique, and we assume we will be continuing with our example that we assume that we were given a project to study a water scarcity in a certain area. So we were given, say, a timeline of around 3 months. So for that 3 months, we won't be able to collect data for the whole population. So would require a sample and then study the sample and then make conclusions about the whole population, right? So let's go to our systematic sampling, right? So we have some steps that we have to follow when we are doing our systematic sampling. First, we have to give the elements of the population serial numbers from 1 up to n, right? And then we determine our interval using k is equal to capital letter N divided by n, right? So n would be our sample size, and then we would randomly select any number between 1 and k, right? And then we take the elements that from the population that bear the equation, which is s plus t into k, where t is less than or equal to n minus 1 but greater than or equal to 1, right? So in this case, people will be wondering what is the value of t, right? So t is our count sampling, or it's our counting samples, which means it's the numbers we would be counting from, right? So t would be implied, would be equal in this case to 0, 1, 2, 3 up to n minus 1, right? So let's just make an example, right? So we suppose that there are 100 elements in a population, and then we have a systematic sample of 40 elements which we require, right? So using the steps, we would have to give the population serial numbers from our capital N, which was 1000, and our n small letter, which is 40, and then we would use our equation to determine the interval, which would be equal to k is equal to capital N over n, which is equal to 1000 divided by 40, and then it will be equal to 25. So that's our interval. So suppose that we would on our step 3, where we select randomly a number that would fall between 1 and k, right? So suppose that 19 was the randomly selected number. So we would take the numbers that bear s plus t into k, where t is less than or equal to n minus 1 but greater than or equal to 1, right? So in this case, we would substitute n as s, right? So it would be 19 plus t. Our t would be, in this case, 1 subtract 0 into 25, and then it would give us 19, right? So our second number which would derive there is 44, right? So in 44, we would substitute the s, and then it would be 19 plus t, which is 1, and then would subtract 1, right? And then we would times it, we would times it by 25, and then it would give us 44. So 94 would say s plus your t, which would be equal to 2 subtract 1 into k, which is our 25, and then we would have your 94, and then you would say s, which is your 19, plus your 3 minus 1, which would be into k, which is 25, and it would give you 144. So you would do the same thing up until you have your required systematic sample of 40, which is needed. So I have compiled all the numbers from 19 up until 994. So this is the sample which we would use to study water scarcity in a particular area using systematic sampling method in statistics. So for